Hi, everyone. Welcome to lesson number 5. We're going to be talking about physical and chemical changes. Before we get started, I do want to let you guys know that I'm going to try to upload an optional assignment. It's going to be a really fun, not really like a dashboard, but more like a checklist of things that you can do for Earth Day. I'm going to have this be able to replace maybe one assignment that you might be missing. I'll give you more details in the actual slides that will be assign, but just to let you know, I'm going to have to assign it so that you can have your own copy, but it is optional. This is totally up to you if you want to do it or not. All right, so let's get started with our do now. So for our first do now, what phase of matter are the particles in? And number 2, you blow up a balloon in your living room, which is 72 degrees Fahrenheit. You then take it outside where it's 44 degrees. Will the balloon get bigger, smaller, or stay the same? So again, you're blowing up your balloon in your living room. Your living room is 72 degrees. You then take that balloon outside where it's 44 degrees. What do you think will happen to the balloon? All right, let's talk about our do nows. So for do now number 1, we were looking at these particles. And as I'm looking at them, I can see that they're far apart from each other and they look to be moving and colliding with each other and the surface where they are contained. So that's telling me that these particles are most likely a gas. They're far apart. We see these really big action arrows that are telling me that I can infer that they're moving pretty quickly. They're also bumping into each other. And those are very, very common properties of gas particles. For a second do now, we start with knowing that the room is 72 degrees and the outside is 44. That means that the room is much warmer than outside. Yesterday, we looked at some pictures that showed us what the particles in warm air look like versus the particles in cold air. You remember, both of these are still gas particles, they're just gas particles at different temperature. So, because those air molecules would get closer together, that balloon would actually deflate. This is a big problem sometimes in places where the temperature drops really suddenly. Your tires might be flat, and it's kind of for that reason. The air inside the tires has gotten more closer together, which causes things to deflate or get smaller. Today, we are going to be talking about all kinds of changes that we see every day. Things from the minute that you wake up and start brushing your teeth to, when you eat and do all these different things throughout the day. A lot of these things are changes that you're witnessing. And we're going to talk about the two changes that occur on Earth, which are physical changes and chemical changes. So, for physical changes, and we've kind of talked about these before, we know that these are the changes that changes the way something looks, like the size, the shape, the form of something mixing, but it keeps the same molecules. We do not make a new substance with physical changes. You can usually separate it back into its original components. Some things might be a little bit more difficult than others to separate, but in essence, we can always separate it back to its original components. So, for example, something here where you have these molecules, heat was added, and you have these. They're the same molecules, they're the same exact molecules. They're just a little bit farther apart, meaning we changed the way that they looked. Um, and here, for example, in this container, we had these particles of a solid. We added water into the container, and eventually they dissolved. So the red particles were able to kind of go throughout the water, but they're still water particles and they're still whatever this solid substance is, they just dissolved. So, some examples of these physical changes. Um, we know that a physical change changes the size and shape of something. There's a lot of different words that can be said to mean a change in size and shape. I'm not going to just tell you, "Oh, I changed the size and shape of this plate." All right. There's a lot of different words that we can mean that. And so I'm going to go through a couple of those right now. So the first one is like with this balloon, we inflated it with air. That balloon surface stretched. It got bigger. The opposite of that kind of is this Play-Doh where we are compressing the Play-Doh. We started with this Play-Doh here and we compressed it. What does compressing do to the Play-Doh? It makes it smaller, right? It's still Play-Doh, it just looks different. It was compressed, it was made smaller. Next, we have this glass beaker, and it falls and it breaks. We can say that this shattered. That's another word that shows that we changed the appearance. It's still a beaker, it's just in a lot of tiny and dangerous pieces. This is why we don't use glass beakers during class. Next, we have this piece of paper, and it's now torn into multiple different pieces. Again, these are still paper. We just changed the appearance. This is a physical change. We still have paper, so all our components are still there. We could add some tape and make it look like it did before. It's still paper. Next, with a toothpick, we took it and we broke it in half. It's still a toothpick. We altered the shape. We actually made two out of one, but this is still a toothpick. Now, metals have a lot of interesting qualities. I'm not going to go into too much detail because we're going to have a lesson about this later. But metals can be pulled into wires and it can be molded into different shapes. So, if you were to have a sheet of metal like this, you could actually pull it into these wires or cut into these ribbons. And then you can take that actual metal and melt it or create it into all of these different shapes. Doing that does not change the substance. It's still a metal, it just looks different. Now, this is a very important one. This is one that can confuse a lot of people just because sometimes you can't actually see it. But we started off with sugar and then we put it into this beaker of water and we stirred it. What do you think happened? The sugar dissolved. Dissolving is a physical change. When something dissolves, it actually gets broken apart into smaller and smaller pieces. These pieces are too small for us to see, but they're still there. So we didn't actually change anything. We didn't create a new substance. We just changed the shape or the size in it being so small that we can no longer see it. We do know that if you were to taste this water, it would still taste sweet. That's evidence that the sugar is still in there. So, for physical changes, the other thing that can cause a physical change is changing the temperature. So, these are both samples of water, and when we read these thermometers, see, told y'all that reading thermometers would come in handy. When we read these thermometers, we can very clearly see that there are two different temperatures. If you can see, this one is halfway between the 80 and the 90 at that medium line. What temperature do you think that is? It's 85 degrees. Yeah, this is 85 degrees. And this one here is a little bit above the 10. It looks like it's 11 or 12. These are at two different temperatures. Um, the temperature is determined by your surroundings. It's determined by anything that has an effect on it. It doesn't rely on anything chemical. Changing temperature is a physical change. So, for example, and you should know these super quickly, changing in states of matter are physical changes. So, when a solid changes to liquids, we say that they have. Go ahead and use the answer box to fill in the blank. We say that they have melted. So, melting is a physical change. We had this ice, we got this liquid water. It looks a lot different, it feels a lot different, but it's still water. Next, when liquids change to solids, we say that they have, use the box to fill in the blank. We say that they have frozen. If you said solidified, that is also perfectly okay. Right, we have these liquid waters, the change in temperature, it solidifies or it freezes. Again, it changes the way it looks, but it is still water. Next, when liquids change to gases, we say that they have what? Evaporated. When we add enough heat to a liquid, it will begin to boil and eventually you will create water vapor. Again, water vapor. This gas is still water. It's just in a different phase. It looks differently. If we wanted, we could do something to make it back into liquid water. And lastly, when gases change to liquids, we say that they have what? Condensed. And that occurs when we lower the temperature, either through something like a fridge, a cold surface, or by going higher in the atmosphere. Both of these are still water. They just look different. They're in different phases. These are all physical changes. Now, the second type of change are chemical changes. These happen when two substances combine to form a new substance, sometimes more than one new substance. The key word here is new. You are creating something that wasn't there before the change. So if you remember, we had a vocab in motion during a chemical change, right? Our hands were together, the molecules break apart, they rearrange to form something new. I'm hoping that at least half of you did those hand motions. Remember in class when I told you one day you're going to read this and you're going to be doing it? Told you that day was going to come. But yeah, so we know that during a chemical change, those molecules, they break apart, they rearrange, right? They rearrange. This rearranging is what makes it something new. If the particles did not rearrange, they would still be the same ones, meaning that it wouldn't be a chemical change. New molecules are new substances. And once a chemical change happens, they're irreversible. You cannot separate it back into its original components because those original components are not there. They're gone. We created something new. If you had, let's say, oxygen and hydrogen atoms before you started, if you create something new, you can't get those back because it's something completely different. So, kind of like how I was talking here, we have this molecule plus these two molecules. We have a change, a chemical change happen, and we are left with these here. These molecules are not the same as these. They're new molecules, they're new substances. We cannot get our old molecules back because they no longer exist. This is a chemical change. When substances are placed together and a chemical change occurs, there's often clues that this happened. I'm going to go through a couple of these. The very first is an unexpected change in color. This is one of the most common ones, which is rusting. You change the color of the metal through the interaction of water, metal, and exposure to oxygen. But you get this rust, this change in color. This can also happen. I don't know if you remember when I said if you put let's say you put a white liquid or a clear liquid onto a white powder, you expect it to stay clear or to stay white. But if it turns red, right, that's an unexpected color change. That would show that it may be a chemical reaction. Next, we have a liquid being poured into another liquid and we have a precipitate forming. Now when we see this, the first thing that we think is, oh, we changed the color. The change in color is definitely one of the most obvious ones, but what happens when a precipitate forms is that you have two liquids that are coming together and a solid is forming. So if you give it enough time to go from this where it's mixing all the way until it kind of just settles, you'll see that there are all these solid particles that have now settled at the bottom. We didn't put a solid into this liquid. We mixed two liquids and we ended up with a solid. That is a chemical reaction, an unexpected change in phase. The most common one is bubbles. Bubbles happens when substances are placed together and you get a gas is released. So if you pop a bubble, right, it seems like there's nothing in there, but you actually just released the gas that was formed during the chemical change. A lot of the times, and this is one thing that I didn't mention in class, but a lot of the times gas creation is accompanied or it's followed by odor or a smell. You guys did see this when we did that example of oh my gosh, what was it? The phenol red color indicator, and we put it in that plastic bag. We definitely, when we opened it, right, we smelled smelled really, really gross. It's because a gas had been formed and that gas had a different odor. Oops, sorry, too fast. Um, the next one is light or heat are given off. Again, in that same experiment that I was just talking about, we felt that the bag got really hot and we combined two things that were cool or at room temperature and they got hot on their own. But another big one is light being given off. For example, you put two liquids here, all of a sudden it became fluorescent. You have this light being given off. Fire is also another really big one where light and heat are given off. Basically, anything with fire is a chemical reaction. You cannot get anything that has been put through fire back, right? These logs here, at the end of the night, they're going to be ash. There is nothing that we can do to recuperate our logs. It's become something new. All right, so now it's your turn. I'm going to go through a couple of slides, and in the box too that's going to pop up on the right, you're going to tell me if it's a physical or a chemical change. Making a sandwich. Making a sandwich, you're getting all of these different things and you're placing them together. This is a physical change. We're not actually changing the cheese, right? The cheese is still cheese. This bologna looking thing is still bologna. Pickle's still a pickle. We're mixing it together, but the actual components are still the same. We can get everything back if we just take it apart. Next, baking a cake. Baking a cake is actually a chemical change. While we do make a mixture in the beginning with the batter, as soon as we begin to cook it, we actually form new chemicals. Bubbles are formed, it's changed through heat. This is a chemical change. We definitely cannot get our original substances back. Everything has been cooked. Metal resting. This is a chemical change. It's an unexpected change in color. The reaction of the oxygen and the water made something new, made this rust that is on the metal. What about this crayon art? So she takes these crayons and she tapes them to the top of this easel looking thing, and then she takes her hair dryer and starts doing this. Is this a chemical or physical change? This is a physical change. By using the heat of that hair dryer, all she's really doing is melting the crayons. She's changing the appearance of the crayons by changing the phase that they are in. This is a physical change. Breaking plates. Do not do this at home, y'all. I don't want to get calls saying, Miss Vallejo told us to break plates. But breaking plates, is this a physical or a chemical change? This is a physical change. All of these plate pieces that are flying around, these are still pieces of plates. They're just changing appearance. Fireworks. This is a chemical change, right? We're taking this powder, we're lighting it up, and you get these huge displays. And the two big ones, right? The two big clues is that really loud sound that is produced, as well as the light that is produced. This is a chemical change. Rotting food. Didn't talk about this one, but we should know it. This is a chemical change. They're going through certain processes that are completely changing the food into something new. Ice melting. You should know this one really quick. This is a physical change. It's still water, we're just changing its appearance. We're changing the state of matter that it's in. Fire. And this is a chemical change. We know that anything that has to do with fire is always going to be a chemical change. So let's go ahead and recap, which of course you know means it's time for our major keys. Major key number 1. Physical change happens when the form of the matter changes, but the molecules stay the same. Like here, we took this pencil, it got broken, still a pencil, we just changed the way it looks. All of the molecules in it are still the same. Major key number 2. A chemical change happens when a substance combines with another to form a new substance. You cannot get back your original components. Okay. For example, here we combine this egg with hot oil, with heat. It started cooking. It's changing into something new. We cannot get our original egg back. Major key number 3. There are clues that let us know that chemical changes have happened, and the most are unexpected temperature changes, bubbles. This means that a gas is created, and it usually comes with a smell or an odor. Color changes like rusting, sounds, light, and anything cooked or with fire. Which brings us to our last discussion question. Mario and Harry are working together to make s'mores. Hashtag quarantine snacks. Harry chops the wood and breaks the graham crackers and chocolate bars in half, while Mario lights the fire and roasts the marshmallows. Who is in charge of the physical changes in the snack making process? And who is in charge of the chemical changes? Make sure to provide specific evidence from the story. And that's it. Make sure to watch the video all the way till the end to make sure that your answers get automatically submitted. If you can go back to Google Classroom and click completed, that'd be great because it's just easier to count that way. Don't forget to log into Illuminate by Friday to take the physical and chemical changes exit ticket. Have a great rest of your week. Hope everyone is happy, healthy, and safe. See ya.